Databases are fundamental for managing information. Within these, Oracle Database stands out for its reliability and scalability. Data retrieval speed is crucial for any database system. Indexes are a core component that significantly accelerates data access. They are like signposts, guiding the database to the desired data quickly. Imagine searching for a book in a vast library without a catalog. It would be a daunting task. Indexes are the catalog for a database, enabling swift data retrieval. Understanding and managing indexes is crucial for any Oracle database administrator, ensuring optimal database performance. This deep dive explores various index types in Oracle Database. It delves into their creation, monitoring, and optimization, providing a comprehensive guide for both beginners and seasoned administrators. This knowledge empowers you to unlock the full potential of Oracle Database, ensuring efficient data management for your applications. B-tree indexes are the most common type in Oracle Database. They are exceptionally versatile and efficient for various data types and query patterns. These indexes resemble a hierarchical tree structure, allowing for fast data searches, insertions, and deletions. B-tree indexes excel in handling queries involving ranges of values, comparisons, and equality checks. They are highly effective for queries like find all employees with salaries between $50,000 and $100,000. The balanced nature of B-tree indexes ensures that no single branch becomes overly large, maintaining consistent performance. This makes B-tree indexes suitable for most database operations and a cornerstone of efficient data retrieval in Oracle Database. Bitmap indexes are specialized indexes that excel in specific scenarios. They are particularly effective for columns with a low cardinality, meaning a limited number of distinct values. Consider a gender column with only male and female values. Bitmap indexes shine in such cases. These indexes use bitmaps to represent the presence or absence of a value for each row in a table. This compact representation enables efficient processing of queries involving multiple conditions on low cardinality columns. Bitmap indexes are particularly beneficial for data warehousing and analytical queries, where complex conditions on low cardinality columns are common. However, they are less suitable for frequently updated data, as updates can be costly due to the need to modify the bitmaps. Function-based indexes offer a powerful mechanism for optimizing queries involving functions on table columns. Imagine a query searching for employees based on the uppercase of their last name. A function-based index on the function would significantly speed up such a query. These indexes store the computed values of the function, enabling direct access based on the function's result. This eliminates the need to evaluate the function for every row during query execution, resulting in significant performance gains. Function-based indexes are invaluable for optimizing queries with complex calculations or manipulations of column data. They provide a targeted approach to improving performance for specific query patterns involving functions. Reverse key indexes address a specific performance bottleneck encountered in high-volume insert operations. In standard B-tree indexes, frequent insertions can lead to contention as new entries are added to the same leaf blocks. Reverse key indexes mitigate this by reversing the key value. This reversal distributes the insertions across different leaf blocks, reducing contention and enhancing concurrency for insert-heavy workloads. This is particularly beneficial for applications with high transaction rates and frequent data modifications. Reverse key indexes are a specialized solution for addressing specific performance challenges related to concurrent insertions. They provide a way to maintain optimal performance even in environments with high insert activity. Index-organized tables represent a unique approach to data storage within Oracle Database. In traditional tables, data is stored separately from indexes. In contrast, index-organized tables integrate the table data directly into the B-tree index structure. This integration eliminates the need for separate data blocks, as the index itself contains the table data. This results in faster data retrieval, as accessing the index directly retrieves the corresponding data. Index-organized tables are particularly beneficial for applications demanding extremely fast data access. They are, however, less suitable for tables with frequent updates, as updating the index structure can be more expensive due to the integrated data. Creating indexes is straightforward in Oracle Database. The command provides the foundation for index creation. You specify the index name, the table, and the columns to be indexed. For instance, the command creates an index named on the table using the AND columns. Oracle Database then automatically determines the appropriate index type based on the data type and other factors. Additional options within the command allow for fine-grained control over index creation. These include specifying the table space for the index, choosing between unique and non-unique indexes, and defining advanced parameters for index organization. Monitoring index usage and effectiveness is crucial for maintaining optimal database performance. Oracle Database provides various tools and techniques for monitoring indexes. The view offers valuable insights into existing indexes, including their size, table, and columns. Furthermore, the package provides comprehensive statistics about index usage. You can gather information about how often an index is used, whether it is being used effectively, and whether it needs optimization. Regularly monitoring index usage allows you to identify underutilized indexes, indexes that might be hindering performance, and opportunities for optimization. It ensures that your indexes are actively contributing to efficient data retrieval. Optimizing indexes is an ongoing process that aims to ensure indexes are used effectively and contribute to optimal database performance. One key aspect of optimization is rebuilding indexes that have become fragmented over time. Fragmentation can occur due to frequent data modifications, leading to reduced efficiency. The command allows you to rebuild an index, eliminating fragmentation and restoring optimal performance. Additionally, you can analyze indexes using the package to identify potential areas for improvement. Regular optimization ensures that indexes remain efficient and adapt to changing data patterns. It's a continuous process that contributes significantly to maintaining optimal database performance over time. Indexes are indispensable for achieving optimal performance in Oracle Database. They serve as the backbone of efficient data retrieval, enabling fast and responsive access to information. Understanding the different types of indexes, their strengths, and their limitations is crucial for any database administrator. From the versatile B-tree indexes to the specialized bitmap and function-based indexes, each type caters to specific needs and query patterns. Mastering the creation, monitoring, and optimization of indexes empowers you to unlock the full potential of Oracle Database. By implementing sound index management practices, you can ensure that your database remains efficient, scalable, and capable of handling demanding workloads. Proper index management translates directly into faster data retrieval, improved query performance, and an overall enhanced user experience.